Hello, in this lecture we will find the area of the black triangle. We can see in the drawing a rectangle that contains three right triangles. We know the areas of those three right triangles. The area of this right triangle is 27 units. The area of this right triangle is 12 units. And the area of this right triangle is 15 units. And actually the rectangle contains three right triangles and the blue triangles too. And actually the area that we are looking for, the area of the blue triangle, equals to the area of the rectangle minus the sum of the areas of the three right triangles. So in order to find the area of the blue triangle, the only thing that we need to do is to find the area of this rectangle, and then we will subtract from the area of the rectangle the sum of the areas of those three triangles. Okay, so let's define the width of this rectangle as A, and the length of this rectangle will be defined as B, okay. The width of this rectangle is defined as A, and the length is defined as B, and as you have already know, the area of the rectangle equals to the length of the rectangle times the width of the rectangle. So we can write down that the area of this rectangle, we will mark it as A, abbreviation of area. Area of the rectangle equals to the width of the rectangle times the length of the rectangle. So the area of the rectangle equals to A times B. Okay. Okay, the area of the rectangle equals to A times B. The width times the length of this rectangle. Okay. So let's define the base of this triangle as Y, the base of the triangle that is area is 15 units will be defined as y, and as you can see from the drawing, the base of the rectangle of the triangle that is area is 12 units will be the length of the rectangle that is B minus the base of this triangle that is y. So it is actually B minus y. Okay, the base of the triangle that is area is 12 units equals to B minus y. The width, the length of the rectangle that is B minus the base of this triangle that is y. So B minus y is the base of the triangle that is area is 12 units. Okay. In the same way, we will define the height of the triangle that is area is 27 units, this triangle as x. Okay, the height of the area, the height of the triangle that is area is 27 units will be defined as x. And you can see from the drawing that the height of the triangle that is area is 12 units will be the width of the rectangle that is A minus the height of this triangle that is x. Okay, so A minus x is actually the height of the triangle that is area is 12 units. Okay, now we will create the formulas of the right triangles. Although we know that the areas of those three right triangles, now we will create the formulas for those areas. As you have already know, the formula of a triangle equals to the base of the triangle times the height to the base divided by 2. That is the area of a triangle. The base of the triangle times the height to the base divided by 2 equals to the area of a triangle. Okay, again, the area of a triangle equals to the base of the triangle times the height to the base divided by 2. Okay, we will implement this formula in order to calculate the areas of those three right triangles. And we will start with the area, with the formula for the area of this right triangle. So the formula is the base of the triangle that equals to y times the height of the triangle that is A divided by 2. That is equals to the area of this triangle. but we have already know that the area equals to 15 units, so we can add to the formula that A equals to A, that is the area of the triangle, equals to 15 units. Okay, so the first equation is the formula for the area of this triangle, and the formula is y, that is the base of the triangle, times the height of the triangle, that is A, divided by 2. It equals to 15 units. The area of this triangle is given to us is this 15 units. Okay, we can write again the formula. It is y times A divided by 2 equals to 15 units. Okay, we will form the formula for the area of this right triangle. It will be actually the base of this triangle, that is B, times the height of this triangle, that is X, divided by 2. It is equals to the area of this triangle, equals to A, but we have already know that the area equals to 27, so we can add to the formula that A equals to 27. Okay, so the formula for the area of this triangle equals to the base of the triangle, that is B, times the height of this triangle, that is X, divided by 2. And it equals to A, and we know that the area is 27, so we can add to the formula that A equals, the area equals to 27 units. Okay, so we can rewrite this equation. The second equation is B, the base of the triangle, times the height of the triangle, that is X, divided by 2, equals to 27 units. Okay, the base of the triangle, that is B, times the height of the triangle, that is X, divided by 2, equals to 27 units. The area of this triangle is given to us, and it is 27 units. And we will create also the formula for the area of this right triangle. It is actually the base of this triangle, that equals to B minus Y, times the height of this triangle, that is A minus X, all divided by 2. It equals to the area of this triangle. But we have already know that the area equals to 12 units, so we can add that A equals to 12. Okay, so the third equation is the formula for the area of this triangle, that is equals to the base of the triangle, that is B minus Y, times the height of this triangle, that is A minus X, all divided by 2. It is the area of this triangle, but we have already know that the area equals to 12, so we can add here that A equals to 12. A, the area, equals to 12 units. We can rewrite this equation. B minus Y times A minus X divided by 2 equals to 12 units. Again, the base of this triangle, that is B minus Y, times the height of this triangle, that is A minus X, divided by 2, equals to the area of this triangle that is given to us, and it is equals to 12 units. Okay, so we actually created 3 equations for the formulas of the 3 right triangles, and in the next step we will take x and y out of their equations. First of all, we will take y out of his equations, and then we will take x out of his equations. First of all, we will take y out of the first equation, and then we will take x out of the second equation. So we will start with y. The first equation for y is y times a divided by 2 equals to 15. So we can multiply both sides of the equation by 2. Okay. Okay, y times a divided by 2 times 2 equals to y times a, and 15 times 2 equals to 30. Here we can divide both sides of the equation by a, because a is the width of the rectangle, so a is a positive number, it can never be 0. And that is the reason that we can divide both sides of the equation by a, it is allowable. Okay. So here we divided both sides of the equation by a. We got that y equals to 30 over a. So we take y out of the first equation. We will do the same thing for x. We will take x out of the second equation. So the second equation for x is actually here p times x divided by 2 equals to 27. So here this is the second equation, b times 6 divided by 2 equals to 27. Here we can multiply both sides of the equation by 2. We will get that p times x equals to 54. Okay, b times, after we multiply both sides of the equation by 2, b times 6 divided by 2 times 2 equals to b times 6, and 27 multiplied by 2 equals to 54. Now we can divide both sides of the equation by b, because b is the length of this rectangle, so it can never be 0. It must be a positive number, so it is allowable to divide both sides of the equation both sides of the second equation by b. So we will get that x equals to 54 over b. Okay, after we divide both sides of the equation by b, we got that x equals to 54 over b. b times x divided by b is x, and 54 divided by b is 54 over b, so x equals to 54 over b, and we already know that y equals to 30 over a. Okay, so we took out x and y. Out of their equations. We got that x equals to 54 over b, and y equals to 30 over a. Okay, in the next step we will substitute x by 54 over b and y by 30 over a in the third equation. Okay, again we substitute x by 54 over b and y by 30 over a in the third equation. So the third equation is you can see here, the third equation is b minus y times a minus x divided by 2 equals to 12 units. Okay, first of all, we will multiply both sides of the equation by 2. We will get that b minus y times a minus x equals to 24. Okay, we multiplied both sides of the equation of this equation by 2. We got that b minus y times a minus x equals to 24. 12 times 2 equals to 24. In the next step, as I've already told you, we will substitute x by 54 over b and y by 30 over a. Okay, they are equal to each other, so we can do this thing. Okay, so it is b minus y, and instead of y we will write 30 over a times a minus x, and instead of x we will write 54 over b all divided equals to 24. I'll show it again. B minus y, we substituted y by 30 over a times a minus x, and we substituted x by 54 over b. Okay, they are equal to each other, so we can substitute each by the other. Okay. In the next step, we will subtract 24 from both sides of the equation. We get that okay, b minus 30 over a times 54 over b minus 54 equals to 0. So we subtracted 24 from both sides of the equation. We got here minus 24 because we subtracted 24 from this side of the equation, equals to 0 because 24 minus 24 equals to 0. In the next step, we will open the brackets. Okay. B times A is BA or AB minus B times negative 54 over B is negative 54. Negative 30 over 8 times A is negative 30. Negative 30. Negative 30 over 8 times negative 54 over B equals to positive 1620 over AB minus 24 equals to 0. Okay, we opened here the brackets, so B times A equals to BA or AB, it is the same. Then B times negative 54 over B equals to negative 54. Negative 30 over A times A equals to negative 30. And negative 30 over A times negative 54 over B equals to 1620 over AB. And all here it is minus 24. Copied it as it is, equals to 0. Now we have minus 54 minus 30 and minus 24 equals to negative 108, so we will write it down. A times B, negative 108 plus 1620 over AB equals to 0. So, as I've already told you, negative 54, negative 30, negative 24 equals to negative 108. Here we copied AB as it is here, and 1600 over 20, it is, I copied it here. Okay. In the next step, we can multiply both sides of the equation by AB, and B are positive numbers, so we can do this. It is allowable because A times B can never be 0. When you multiply two positive numbers, the result is always positive, so it will never be 0. So it is allowable to multiply both sides of the equation by AB. So after we multiplied both sides of the equation by AB, we got that AB times AB equals to AB squared. Negative 108 times AB equals to negative 108 AB. And 1620 divided by AB times AB equals to 1620. Okay, and 0 times AB equals to 0. Okay, so we actually got there a quadratic equation, and the variable of this quadratic equation is A times B. So the general formula of a quadratic equation is actually A times x squared plus B times x plus C equals to 0. So this is the general formula of a quadratic equation: A times x squared plus B times x plus C equals to 0. And A, B, and C are coefficients of the quadratic equation. I repeat, A, B, and C are coefficients of the quadratic equation, and x is the variable that we are looking for. Okay, I will write it down. A, B, and C are the variable, are the coefficients of the quadratic equation. And x is the variable that we are looking for. Okay, again, A, B, and C are the coefficients of the quadratic equation, and x is the variable that we want to find its value. And actually, the value of the values of x will be the solution of the quadratic equation, and it is actually also called the root or the roots of the quadratic equation. Okay, so in order to find the value of x, actually we cannot solve a quadratic equation without the special equation for x. We have a special equation for x that will help us to find the value of x, and actually the special equation for x is x equals to minus b plus minus the root of b squared minus 4 times a times c, all divided by 2 times a. So this is the special equation for x. So in order to find the value of x in this quadratic equation, actually we are looking for the value of x, and in order to find the value of x, we will have this special equation that we will use it in order to find out the value of x. The value or the values of x, because x might have two different solutions. As you can see in the equation, x equals to minus b plus minus. So the first solution will be x minus b plus root of b squared minus 4 times a divided by 2 times a, and the second solution for x will be x minus b minus root of 4b squared minus 4 times ac divided by 2 times a. Okay, so we might have two different solutions for x, and as I already told you, these solutions for x are also called the root of the roots of this quadratic equation. Okay, so now we will write down again the general formula for a quadratic equation, and below of this quadratic equation we will write our specific quadratic equation, and we will find the values of a, b, and c that are the coefficients of a quadratic equation. So we will find the special values of a, b, and c in our specific quadratic equation, and we also find, of course, the value of the variable of our quadratic equation. Okay. So what I mean is that we find the value of x in our quadratic equation, and then in order to find out the value of x in numbers, we have to solve this equation for x in order to find the value of x in numbers. Okay, so first of all we write down the general formula for a quadratic equation: a times x squared plus b times x plus c equals to 0. Okay, this is the general formula for the quadratic equation: a times x squared plus b times x plus c equals to 0. And below we will write down our specific quadratic equation that we derived from the three equations for the areas, for the formulas of the areas of these three right triangles. Okay, so our quadratic equation is actually equals to ab squared plus b times x plus c equals ab ax squared plus b times x plus 1620 equals to 0. Okay, so this is the quadratic equation that we derived from the first equation, that was the equations for the formulas of the areas of the three right triangles. Okay, ab squared plus I made a mistake, plus 108 actually I'll write it again. So our specific quadratic equation was ab squared minus 108 ab plus 1620 equals to 0. Now we can multiply this expression ab squared by 1, because any number or expression that you multiply by 1 will not change the value of that expression or that number. 5 times 1 equals to 5. So when we multiply 5 by 1, it doesn't change the value of 5. It was 5 and it remains 5 after the multiplication by 1. So by multiplying a number or an expression by 1, it doesn't change the value of that expression or that number. So we can multiply this expression by 1, and after we multiply it by 1, you can see that a equals to 1, x equals to a times b, and the b equals to negative 108. Again, x equals to ab, and c equals to positive 1620. Okay, again, a equals to 1, x equals to ab, b equals to negative 108, and c equals to 1620. Okay, so now that we know the values of a, b, c, that are the coefficients of the quadratic equation, we can use the special equation for x in order to find out the value of x, and actually in our case x equals to, okay, first of all I will write the values again. X equals to 1, a equals to 1, x equals to a times b, b equals to negative 108, and 16 equals to 1620. Again, a equals to 1, x equals to a times b, b equals to negative 108, and c equals to positive 1620. So after we know the values of the coefficients of our quadratic equation and also the values of the variable of our quadratic equation, we can use the special equation for x in order to find out the solution of our quadratic equation. Or in other words, in order to find out the value of x that in our specific quadratic equation equals to a times b, that is also the area of this rectangle. Okay, so we will use the special equation for x in order to solve our specific quadratic equation. Okay, so we will write again the formula of the special formula for x. Again, the special formula for x is actually x equals to minus b plus minus root of b squared minus 4 times ac divided by 2 times a, where a, b and c are the coefficients of our quadratic equation and x is the variable of the quadratic equation that we want to find. Now we can use this equation in order to solve our specific quadratic equation. So x is actually equals to a times b, as you can see here. X equals to a times b, so it is a times b equals to minus b, so b equals to negative 108. So minus b will be minus 108, that is plus 108. Because minus times minus equals to plus. And then we have plus minus the root of b squared. B equals to negative 108, so b squared is minus 108 squared. Minus 4 times a, minus 4 times a equals to 1, times c equals to 1620, so it is actually minus 4 times 1 times 1620, all divided by 2 times a equals to 1, so it is 2 times 1. Okay, I will repeat again. So in order to solve our specific quadratic equation, we use the special equation for x, and x in our special equation is actually, as you can see here, equals to a times b, and a times b is also the area of the rectangle. Okay, so it is x that is a times b. B actually equals to minus 108, so here minus b is minus 108, that equals to plus 108, and it is plus minus the root of b squared minus 4 times ac, so b equals to negative 108, so b square is negative 108 square times 4 minus 4 times AC. It is 4 times A is 1, and C is 1620, so it is 4 times 1 times 1680, okay? Now we will do the calculations. So A times B equals to 108 plus minus 108 square is equals to 11,664 minus 4 times 1 times 1620 equals to 6,480, all divided by 2. I'll repeat again. Here we have 108 plus minus 108 square equals to 11,664 minus 4 times 1 times 1620 equals to 6,480. So now we will subtract 11,664 from 6,480. We will get that A times B equals to 108. 11,664 minus 6,480 equals to the root of 5,184 all divided by 2. We'll repeat again. 11,664 minus 6,480 equals to 5,184 divided by 4. Now the root of 5,184 equals to 72. So we'll write it down. So A times B equals to 108 plus minus 72 divided by 2. I repeat again, the root of 5,184 equals to 72, so we have 108 plus minus, so it will be two different answers. 108 plus 72, and then we'll do 108 minus 72. First of all, 108 plus 72 is 180. 180. So 108 plus 72 equals to 180, and 180 divided by 2 equals to 90 units. So actually we found that the value of A times B equals to 90 units, and as I already told you, A times B is also the area of the rectangle. Okay, this is the first solution. We must not ignore also the second solution, so we write also the second solution for AB. It's also called the second root of our quadratic equation. So A times B equals to 108 minus 72 divided by 2. So we have the second solution for AB, of the second root of our quadratic equation, equals to A times B equals to 108 minus 72 divided by 2. 108 minus 72 equals to 36, and 36 divided by 2 equals to 18 units. So we got that in the second solution for A times B, that A times B equals to 18 units. But this solution is incorrect, because the area A times B is the area of this rectangle, and it can never be 18 units, because even this right triangle is bigger than 18 units, and the area also actually contains not only this triangle but also this triangle and this triangle. So the total area that the rectangle contains equals to 54 units. And in addition, the rectangle contains this blue triangle, so the total area of the rectangle must be greater than 54 units. That is the sum of these three right triangles. So for that reason, the answer of 18 units is not correct. So the only answer that is left, that the A times B equals to 90 units, and as I already told you, the area of the rectangle that equals to 90 units minus the areas of those three right triangles equals to the area of the blue triangle that we are looking for. So we write it down. The area of the rectangle that is 90 units minus the area of those three right triangles equals to 12 plus 27 plus 15. So as I already told you, the area of the blue triangle equals to the area of the rectangle that is 90 units minus the sum of the areas of these three right triangles, and the sum of the areas of those three triangles, it is actually 12 plus 27 plus 15, okay? And in total, the sum of the areas of the three right triangles equals to 54 units. So the area of the rectangle minus the sum of the areas of the three right triangles is actually 90 units minus 54 units equals to 36 units. I repeat again, the area of the rectangle that is still 20 units minus the sum of the areas of those three right triangles that equals to 54 units. So 90 units minus 54 units equals to 36 units, and 36 units is the area of the blue triangle. Okay, so I write it down. So the area of the blue triangle equals to 36 units. Again, it is the area of the triangle that is 90 units minus the sum of the areas of the three triangles that are 54 units. So 90 units minus 54 units equals to the area of this blue triangle. That is to say 36 units is the area of this blue triangle. Okay, so I'll summarize the lecture. Actually, we wanted to find the area of this blue triangle, and in order to find the area of this blue triangle, the only thing that we have to do is to subtract from the area of the rectangle the sum of the areas of those three right triangles that are given to us. So the only thing that is missing here is the area of the rectangle. That is to say, the area of the rectangle is the length of the rectangle times the width of the rectangle. So it is, in this our case, is A times B. So A times B is the only thing that is missing, because the areas of the right triangles is given to us. So the only thing that we have to find is the area of the rectangle, or in other words, the value of A times B. In order to find out the value of A times B, we created three equations. That is to say, we created the formulas of those, the formulas for the areas of those three right triangles, and actually the formula for the area of this right triangle was the base of the triangle times the height of the triangle divided by 2. It was y times a divided by 2. The area of this triangle was p times x divided by 2, and the area of this triangle was p minus y times a minus x divided by 2 equals to 12 units. And from those three equations that was for the areas of, for the formulas of the areas of those three right triangles, we actually derived a quadratic equation. And in this quadratic equation, A times B was the variable, and by solving the quadratic equation, we found out that there is two solutions for A times B, that is the area of this rectangle. The second solution, that is 18 units, is impossible because the rectangle itself must be greater than 54 units, because it contains three right triangles that the sum of the areas of those three right triangles equals to 54 units, and it also contains blue triangles. So the area of this rectangle must be greater than 54 units. So it is impossible that the area is 18 units. 18 units is incorrect answer. So the only solution that's left for the area of this rectangle is actually 90 units. That is the first solution for A times B, that is the variable of the quadratic equation. So 90 units is the area of this rectangle, and the area of this rectangle, that is 90 units, minus the sum of the areas of those three right triangles, that equals to 54 units. So 90 units minus 54 units equals to the area of this blue triangle, that is 36 units. So the area of this blue triangle equals to 36 units. Okay, thank you very much.